basically take a couple of minutes before it will show your current position. So GPS is basically, I mean, you have many GPS devices out there, so you can just buy these things. I mean, this is not like a subscription service, it's basically free to use. The Americans have opened up the system to everyone. So if you have a device with a GPS receiver, a mobile or a handheld or a route and a car navigation GPS, you can basically use it free of cost, which is a very nice thing. I think there are around 30 satellites out there, all over, spanning the globe. Obviously, wherever you are at the Earth, the number of satellites that you can see will differ. Even more in the mountains, you will not always have a clear air view of, I mean, in all directions. So sometimes when we go trekking, we won't even have proper signal. As normally, you need around 3, sometimes even 4 satellites in a clear view, clear to air view, before the GPS can lock. So in this example, you can see that I mean, there are like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of the 30 satellites are visible from this location. So after, I mean, so here you see for each of these satellites, you see the level, I mean, the signal level. So for some satellites, the signal level will be better because the visibility to these satellites are better. The yellow one here is a bit less powerful signal, maybe because it's closer to the horizon, or there might be some buildings or some trees in between you and the satellite. But basically, you will try to have, I mean, the GPS will initially during boot up try to make a lock with as many satellites as possible. And when you have a good amount of satellites, I think it's a combination of number of satellites and the signal strength. After that, it will use some kind of formulas, whatever, I mean, data transmitted by these satellites. These are one-way satellites, so you are just receiving. It's not two-way. The GPS device will not sending anything back to the satellite, so you're just receiving data from this satellite, probably some kind of location data. So by receiving different data from different satellites, the GPS will be able to figure out what is your location. There will always be an error factor. So you will never see like your exact location up to the millimeter, so there will always be something. Best location is typically around 15 feet, which is around 3 meters, that you will get when you have like very clear, like a flat surface, and you get a clear view to all the satellites. And then basically it will display your exact position. Exact position will be given by a latitude and a longitude. So basically if you look at the Earth is like a ball, or an approximate ball. And if you go around this ball, around the Earth, around the equator, the entire Earth will be divided in 360 degrees horizontally. And if you go vertically around the equator, I mean around the meridian of Greenwich, so then also they have divided the entire globe in 360 degrees. So basically 316 lines, which will give you various distances between the North and the South Pole. So basically, your position on that ball will be uniquely identified by your vertical position. So your, I mean, I guess the latitudes between the North Pole, which is probably 180 degrees north, and the South Pole, which is like 180 degrees south, and your distance away from London, from, I mean, the Greenwich, meridian of Greenwich, which is basically 0 degrees at London. And if you go further to the east, you will go up to 180 degrees east. If you go to the west of Europe, west of London, then you will see like 101 degrees up to 180 degrees west. I hope what I'm saying here makes sense. So, at this moment, I can probably open our good old Google Earth, and then you can actually perfectly visualize this latitudes and longitudes. So I just put a grid on top of Google Earth. So let me just quickly start this thing to just visualize the latitude circles and the longitude circles. Google Earth. This might take a little bit of time, but we'll anyway have to come back to Google Earth a little bit later in the workshop, when we will visualize some of our trails that we have tracked along, and visualize those trails in Google Earth and after the track So let us just start here. It might take a minute because it requires a bit of bandwidth. So here you see again the same ball, the same Earth. If I enable latitude and longitude lines, we can go to grid here. Voila, here, this is what I was trying to say in words. So if you look at your position, so let's go to India. A picture always says more than 1,000 words, as usual. Let's go somewhere to Chennai. Like you can see that boom, 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 boom. Let me click it to the north on top. So let's get a little bit of resolution coming here. So say for example this place, this is Pulikat Lake, right? This big lake on top of Chennai, this is probably Chennai here. Or let's take Chennai itself. If you look at what is the unit position of Chennai, Chennai is obviously to the right of Europe, to the right of London, so that will be east. So Chennai is located 80 degrees east, which is, what is it, latitude or longitude? Longitude, I guess, along the equator. And so if you draw again, I mean, if you zoom again out on the entire Earth, let me start a little bit, so you will see that the entire Earth is basically and if you zoom a little bit then on India here, so Chennai is indeed located then somewhere at 80 degrees, somewhere in this. You actually have to zoom in a little more to get a little bit more precision. So if you want to see the exact position here, voilà. So here Chennai, so a unit position is actually determined using degrees, minutes, and seconds. So those 360 degrees, both horizontally and vertical, every degree will again be divided into 60 minutes. Every one of those 60 minutes again will be divided into 60 seconds. And then they will even give like decimals behind the comma, so you can add 24 seconds, 0.52. So every second in terms of latitude and longitude corresponds to around 30 meters. And so if again you divide a second by 100, if you make like 2 digits behind the comma, then you can actually determine your position to 3 meters precision, which is fairly accurate. So if you look at this location here, this location is located. So this 80 degrees here basically corresponds to this line. So at this line somewhere, and this line goes to Madras. That's 80 degrees east, 16 minutes and 12 seconds. So then the next location they show here is this line. This line is 80 degrees, 18 minutes and 36 seconds. So the difference between this is 1, 2, 3, 4. So 1, 2, 3, 4, yeah. So this is again divided in, I mean, it's like a distance of 4 grids between each of these numbers. So every grid will correspond to, so the difference between these two is 2 minutes and 24 seconds. So if you divide it by 4, 2 minutes and 24 seconds,